This is an AS maths question on integration, particularly finding the area under curves. Figure 4 shows a sketch of part of a curve C with equation y is equal to 32 over x squared plus 3x minus 8. So this is the curve C here in the diagram for figure 4. The point P with coordinates 4, 6 lies on C. So that's this point here, and I can see that it's the intersection of the curve C and this line, which is labeled as L. And it says that the line L is a normal to C at the point P. Now, normal means that it's perpendicular to a tangent that would be at this point P. The region R, shown shaded in figure 4, is bounded by the line L. So you could think of bounded as being the boundary, the outline, the perimeter of this region R. So the line L, the curve C, so is another part of the perimeter, the boundary of the shape. The line with the equation x equals 2, that's this line here, and the x-axis at the bottom. And what we need to do is show that the area of R is 46. Now it says in italics here, solutions based entirely on graphical or numerical methods are not acceptable. That means we are not to try and estimate the area by dividing this shape up into things like rectangles or trapeziums, anything like that. Not an estimate of the area, but an exact value of the area, which will probably mean we're going to be using integration at some point to do that. So the first thing I'm going to do is to divide this area up into two parts. I'm going to draw a dotted line here. And what that does, that divides this area up into this area which is underneath this curve C, and this area here which is looking pretty much like a triangle. Now the dotted line that I've drawn goes vertically down from this point P, and I know the coordinates of P, it's 4, 6, so let's mark that in on the diagram. So I'm just going to go across here to the y-axis, that's going to be a coordinate of 6, and if I go down here to the x-axis, that'll be a value of 4. So what I'm going to do, I'm going to call the region R one part R1 and one part R2. So my total area, my total region is going to be given by the area of R1 plus the area of R2. Now what I'm going to do is I will be using integration to find the area of R1. It's meant to be an integration symbol. And here, well, basically it's just a triangle. So I will be using half base times height to find the area of that. And then I can add those two parts together. So let's start with R1, finding the area of this bit here. And this is the integration part of the question. So I'll write down area of R1 is going to be equal to the integration of 32 over x squared plus 3x minus 8 with respect to x, and my limits are going to be x values of 2 and 4. So let's put my limits in of 2 and 4. Before I integrate, I want to write this 32 over x squared as 32 x to the power minus 2. I just find it a bit more straightforward integrating when it's written in that form, plus 3x minus 8 dx. So now I can do the integration. Now remember, when we integrate, what we do is we add 1 to the power, divide by the new power. So if I add 1 to this power, it's going to be negative 1. And if I divide this by that new power, I'll get negative 32, because 32 divided by negative 1. So that's the first part. The 3x, again, we add 1 to the power, so it'll be 3x squared, and you divide by that new power, which is 2, and negative 8, that's going to become negative 8x. Remember, numbers just become the number and the letter, because this is basically 8x to the power 0. Add 1 to that, becomes 8x to the power 1 divided by 1. So I have my limits. We can now substitute in the limits. So I will have negative 32 times by, now what I'm going to do, I'm going to rewrite this part as 32 over x, negative 32 over x. It's just because I'm going to find that a little bit easier to evaluate this on my calculator rather than typing in to the power negative 1. So putting in the first limit of 4, it will become negative 32 over 4 plus 3 times by 4 squared over 2 minus 8 times by 4, and then we subtract from that what we get when we substitute in the limit of 2, so that will be minus 32 over 2 plus 3 times by 2 squared over 2 minus 8 times by 2. Now when you're evaluating things like this, it's always best to work out each part separately and write down what you get rather than try and do it all in one go on your calculator. So the first square bracket here gives me a value of negative 16, and I'm going to subtract from that what I get from evaluating the second square bracket. And I guess the easiest thing to do is just to scroll back on the calculator and replace each of the 4s with 2s, which is what I'm doing at the moment. And I've just got the last one to do. 8 times 4 now becomes 8 times 2, and that will give me negative 26. So I'm going to be subtracting negative 26, and so that gives me a value of 10. So this is my area for R1. So I'll just highlight that. I now need to find the area of R2. Now to find the area of R2, it's just a triangle. I'm just going to do half base times height. Now I know the height of this triangle here, that is just 6, the y coordinate, but what I don't know is this coordinate here where L2 intersects the x-axis, and without knowing that coordinate I can't work out the length of the base. So what I need to do before I can find the area of the triangle is to work out where does L1, or sorry, where does this line L intersect the x-axis. Now to find that intersection I need to find the equation of L1, and to find the equation of L1 I need a point that it passes through, which I have, 4, 6, and I also need its gradient. Now because it's a normal to the curve, if I can work out the gradient of the curve at this point P, I can use that to find the gradient of a perpendicular line, the gradient of the normal, and then use that gradient along with the coordinate 4, 6 to find the equation of L1. So step number 1 is to differentiate this function here to find out what the gradient is, the gradient function, and then use that to find the gradient at P. So let's start by finding dy dx. Let's differentiate this. Now I've got it written in this form, so I'll use this here. So remember, when we differentiate, what we do is times by the power and then subtract 1 from the power. So 32 times by negative 2 will give me negative 64. X, subtract 1 from the power, that will be negative 3. 3 x, and that will just become 3. Now I can write that as negative 64 over x cubed plus 3, and what I want to do is to find the gradient of C at the point P, that is when the x coordinate is 4, so I'm going to be substituting in x is equal to 4. So I'm going to be finding the value of dy dx at this value of 4. And let's do that. So negative 64 over 4 cubed plus 3. So we have negative 64 over 64. So that's going to be negative 1. So negative 1 plus 3 gives us a gradient at P of 2. Now that's the gradient at P. I want to know what the perpendicular gradient is at that point. So I'm now going to be working out the gradient of the normal at P, and that will be the negative reciprocal of 2, so that's going to be equal to -1/2. So this is the gradient of the line L. I have the gradient, I have a point that it passes through, so I'm now going to use y minus y1 equals mx minus x1 to find the equation of this line L. So y minus y1, that's 6, is equal to -1/2, and then x minus x1, so that's 4. Now, this is the line of the equation of L. I want to find where L crosses the x-axis. It will cross the x-axis when y is equal to 0. So we'll substitute 0 for y into this. That will give us -6 is equal to -1/2 x minus 4, and we just solve for x. So if I times both sides by -2, I will get 12 is equal to x minus 4, and that will give me a value of x equal to 16. Right, so now I have this coordinate here, which is 16. Let's mark that down, 16. Now I have that, I now can work out the length of the base of this triangle, and that's going to be 12. So a height of 6 and a base of 12. So let's just clear some of this here. So now what I can do is now write down my working for the area of the triangle now that I have that coordinate. So that will be half the base, half times by 12 times by 6, and that gives me an area of 36. So this is my area of R2. Now, way back at the beginning of the question, I said that my total region is going to be R1, which is 10, plus R2, which is 36, and that indeed equals 46, as they required us to work out.